diffraction questions. I'm just going to do one. Actually, I'll do the other one afterwards. Today we're going to look at calculating the angular separation between the two third order images formed when blue light of wavelength 442 nanometers is incident on a diffraction grating of 600 lines per millimeter. So to calculate angular separation, that's our formula down here. D sine theta is equal to n lambda. So let's write out the information that we have, and I would really recommend doing this in the exam so you're really showing the examiner that you know what you're doing. So we can see between the two third order images, so the order of the images, that's n, so n is equal to 3 in this one. Wavelength is 442 nanometers, so we need to convert that, as that's going to be lambda is equal to 442 nanometers is by 10 to the minus 9 meters, and then it tells us it's incident on diffraction grating of 600 lines per millimeter. So the 600 lines in a millimeter. So what you need to think about there is how many lines are going to be in a meter, because we need to convert that to meters. You multiply that by 1,000. So we'll have, let's say, 6. So that's 0 lines per meter. And then to find the distance between those, you need to get the reciprocal of that. So if you have any questions about that, just let me know. It's just 1 divided by the answer, and then that will give us 1.67 by 10 to the minus 6 meters, and that is going to be equal to D. Okay, so look at this between the slips, then we can go ahead and fill it in. So the formula is here, we need to rearrange it. So it's going to be sine of theta is equal to n lambda divided by the distance. So sine theta is going to be equal to 3 times the wavelength, 442 by 10 to the minus 9, all over the distance, 1.67 by 10 to the minus 6. And then to get theta, it's going to be sine inverse of that. So just pop it into my calculator. Sorry. Be doing this with me as well, I suppose. So it's going to be sine inverse 0.794, and then theta is equal to sine inverse answer. So theta is equal to 52.56 degrees. And then what you need to think, if you look at the picture here, I know this only goes into n equals 2, but what you found is you found this angle here. So to get the distance between the two third order images, it's going to be twice that. Okay, so you need to times that by 2, so don't forget that at the end. And our final answer is 105